Hello everyone. Today we're going to do a truss analysis using method of joins, and we are going to find all the member forces for each member. So this is a given truss, and we'll put label A, B, C, and D. So when analyzing the truss, um, generally we go for finding the determinacy, but since the question is already asking for an actual member, so we don't have to show that it is determinate. It's already by default we assume that it is determinate structure, which means that using only equilibrium equation we can solve all the forces. So we'll put all the find all the length. So this is 4 meter, and this is 4 meter, and this is from B to D is 3 meter. So A to B has to be square root using Pythagoras theorem, 4 square plus 3 square, and that will give you 5 meter. So that means this value is 5 meter. So once we find the length, we can show that this is theta, and this also will be theta, and this also will be theta. Using corresponding angle, we can also show that this will be theta. The reason we draw the inclination is so that we can find, because this is an inclined forces, you can see that this is an inclined forces, and our um, coordinate system is x and y. So we have to resolve this member into x and y. So for that we will need to have um, cos theta, which is uh, 4 over 5, and sine theta, which is 3 over 5. And this is important to solve so that it will fasten our calculation. If we already solve the cos theta, sine theta from the beginning, it help us to fast do the calculation quick. Okay, so once you have done, the first step is always identify the zero forces. And here we have to look at each joint. So this joint has, we have to draw also the direction for your reaction. So we'll name that as AX, AY, because it's along Y direction in the global axis, and this will be AX, and this will be CY. So we have drawn all the direction of the reaction support, and now we look at the joint. This joint has four uh, forces, so we can't say anything about zero forces. This one has five forces. You can see that 1, 2, 3, 4, 5. So they have five forces, and this one has 3, 1, 2, 3. But because they are not in straight line, so we cannot say anything about the zero force member, because the zero force member, um, if you look back to my video that I talk about things to learn when analyzing the truss, zero force member is either this one, if two members are um, if there are two members, and both of them will be a zero force member at a joint. If there are three member forces and two are in collinear or straight line, then the third one will be equal to 0 irrespective of what angle is. So in this case we have to look for those conditions. So here's 3, but they are not in straight lines, so we cannot say anything about zero force member. However, at joint D we see that both of these forces are straight line. So because both of these are straight line, that means this one will be equal to 0. And if you wanted to show, like you wanted to prove that they are 0, just pick a joint D, and remember that the sign convention always tangent, so that means always point toward away from the joint. So this is FDC, and this is FAD, and then this is FBD. So you'll see that if I take summation of y is equal to 0, you'll see that FBD is equal to 0. So your FBD is a zero force member. And because the FBD is zero force member, you can also show that if you take summation of fx equal to 0, you'll have minus FAD. Anything that points uh, uh, opposite to the global axis x, this is our global axis x, so anything that point opposite to the global axis will be negative, and then plus FDC equal to 0. So you can show that FDC is equal to FAD. So now uh, since both of these are equal, so now all you have to do is find 1, 2, and 3. So you don't have to find all the forces because you already know the relationship. So this is why identifying the zero force is very important. Okay, so once you have the identify the zero force, now the remaining is how to solve the member forces. So this, if you take us as join, this is already zero, so it's already known. So if I have to redraw it again, sometimes it's helpful to redraw the truss again, so that you don't get confused. So we have here, we have this join, we have this reaction cy, ay, and then ax, and then we have this join b, and this is joins d, this is a, this is c. Okay, so those are the remaining of the truss structure. The reason we remove this one is because they are zero force member. Zero force member means they won't take any load. So, and then this is 15 kilonewton, and this is 20 kilonewton. Okay, so just to remind you that uh, only during this load condition this force is equal to 0. If I have an extra load here, then this force cannot be equal to 0. So if I have any load over here, then this cannot be equal to 0. So please remember that zero force member is only applicable at a specific at a given loading. If you change the loading, they may not be equal to 0 anymore. Like I give you example, if you have a load here, then this cannot be equal to 0 anymore. Okay, so please keep that in mind, that zero force member doesn't mean that it has to be always a zero force member, but only for that given loading. Okay, now we have we can so can we use method how do we use method of join? Using method of join, you need to have not more than two unknown member. So in this case, this is unknown, this is unknown, this is unknown, this is unknown. We cannot use this join. And in this case we have this is unknown, 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 so we cannot use that join. And in this case we have this is unknown, this is unknown, however these two are known, so we can use at join B. But but sometimes it's good to find all the support reaction to solve the uh, to solve your um, trusses. So let's find the support reaction ax, ay, az. So number second one is find the support reactions. So in order to find the support reaction, uh, we can take summation of all the forces, summation in this case, and summation of all the moment. In this case, I know that if I take summation of the moment at A, only Cy will be unknown. So I will just do that to fasten my calculation. So I'll take summation of all moment about A is equal to 0. And what forces do you see about A? So we'll find here that this Cy, because this is a perpendicular distance, so it will apply a counterclockwise moment. And remember that uh, if it is counterclockwise it's positive, and if it is clockwise is negative. So we have cy into 8 meter, and this is counterclockwise. And then let's look what else we have. We have this force is about A, so we have this if we extend this, this will be our perpendicular distance, and because of this it produce clockwise moment. So which means that we'll have minus 15 to 3 meter. And then lastly we have this force. This is our perpendicular distance, so it will produce clockwise moment. So we have plot 3, this will be clockwise, that's why it's negative, and then we have negative 20 to 4 meter, and this is because we have clockwise equal to 0. So finally we have 8 cy is equal to 125, and cy will be finally equal to 15.625 kilonewton. And because it is positive, the value is positive, which means that it agreed to our assumed direction. So we are going to put that as it is. So we have all the support reaction cy. Now once we have cy, we can find all the summation of all the forces in y direction. So we have y direction, y direction, and y direction. And the sign convention is upward is positive and downward is negative. So in this case you'll have ay, which is upward, minus 20, which is downward, plus cy, which is upward again, equal to 0. So if we put all the cy here, which is equal to 15.625, you'll see that ay will be equal to 4.375 kilonewton. Again, if it is positive, that means it agrees to your assumed direction. And now we do the third one, which is summation of all the x equal to 0. And in this case we have if it's moving along the x, because our global axis is in this direction, so it's going to be positive, and if it is in the opposite direction it will be negative. So we have ax plus 15 is equal to 0. So in this case we have ax is equal to minus 15 kilonewton, and minus means your direction should be opposite. So we put the opposite direction. So that's how you solve all the support reaction. And please remember that when we solve for the uh, in the calculation, we'll use a x as negative. Okay, so we'll just replace as if we're not going to change the direction in this calculation. We'll change the direction only if needed at the end, but when doing the calculation, please stick to the same direction that you have uh, initial direction that you have considered. So I will still work with all this, and if one of those values is negative, I'll just replace them as negative. Okay. So let's see what do I mean by that. So now using method of join, I'll say join A. We have FAD, and then we have FBA, and this is theta, and we have AY and AX. So you see that I did not change the direction, I keep them as it is. So if you take all the summation of y equal to 0, you'll have FBAY plus AY, because FAB is is an inclined forces, so we can draw the resolving them into x and y direction. So we have FBA y component, and we have FBA x component, and that will be equal to 0. So FBA is sine y is sine theta plus AY equal to 0, and we know that AY is 4.375. So from here we also know that sine theta is 3/5. So from there we can find an FBA is equal to minus 7.291 kilonewton. And because it is negative, which means that it is compression, because we always assume that it is tension, but if it is negative, then we know that it is compression. And we can do the same thing also. So that is FBA, and now we can take summation of all the force in x direction. We'll have AX plus FAD plus FAB x component equal to 0. So this implies that AX plus FAD plus FAB cos theta, this is FBA. It doesn't matter whether it's FAB or FAB, but just for the sake of consistency, put FBA cos theta is equal to 0. So in this case, you have AX, which is negative 15, and cos theta, which is 4 over 5, and FBA will have minus 7.291. So if you put all those values, you'll find that FAD will be equal to 20.833 kilonewton. And because it is positive, so we say that FAD will be in tension. So once we have all those forces, now we have here FAD. It will be 20.83 in tension, and then we have AB, which is 7.291 in compression, and this also we know that it is equal. So now the only remaining is FBC. So we are going to take adjoint C, adjoint C, we have FCB, and we have FCD, and we have CY. So if we take all the forces in y direction, we'll have FCB y plus CY equal to 0. So this will be FCB sine theta plus CY equal to 0. And we know that sine theta is 3 over 5, and CY is 15.625. So if you put all the value, you'll find that FCB is equal to minus 26.042 kilonewton, or 26.042 kilonewton compression. So if you put the value, you'll find that this value is 26.042 compression. So there you have all the value of your member forces, and that's how you solve the using method of join. If you, let's say that in the exam, if you have time to review, so you can do a verification whether it's true or not. This is only if you have time to review. In that case, you'll take adjoint B. This is 20 kilonewton, this is 15 kilonewton, and this is FCB, and this is FBA, and all these are theta. You can do summation of all x equal to 0. You'll get minus FBA x component plus FCB x component plus 15 is equal to 0. So this will be FAB cos theta plus FCB cos theta plus 15 equal to 0. And this will be 4 over 5. This will be 4 over 5. And you'll find FAB is minus 7.29 and FCB is um, minus 26.04. And if you plus them together, you'll get 0 equal to 0, which means that it is verified. So which means that all the values that you have calculated for your member forces, it will be it is correct. So with that, I hope that you will have some steps on some clue on how to apply method of join in truss analysis. Thank you.